So, we're doing a lot of polls right now, right? So when they ask you, who are you going to vote for, Gary Johnson, Jill Stein, Hillary Clinton, or Donald Trump, is that a true binomial distribution? No, that's a quadnomial distribution. We don't do that. Now, just so you know, when you do that, that is very difficult to do, especially if it's a close race. It's very difficult to predict, even for the professional pollsters, okay? So really, a true binomial, you've only got two options. Yes, no, true, false, Donald or Hillary, something like that. Now, I'll let you kind of get away with an I don't know, but technically that's a trinomial, that's not a binomial. Those are harder to deal with. So today we're going to be talking about 8.2, which is distribution of the sample proportion. Okay, now I asked that first question and I didn't get any very good answers. When we're talking about finding probabilities for binomial distributions, we've got at least three ways, right? What are the ways you guys can think of for finding probabilities of a binomial distribution? What?
Yeah.
Okay, so the combination, so you can use the formula, combination n choose x, p to the x, q to the n minus x, right? Okay, so that's one method. What's another method? If you're using a computer especially. Binom dist, right? Now technically, those are the same thing, right? Those are the same method? Okay, it's just that.
That's when you have a z-score and you plug it into that.
No, you don't need any z-scores for this. Okay? Since you mentioned z-score, what is that called? You can use a z-score. What is that method called? The normal approximation of the binomial. Okay? Now, which method is most accurate?
Computer.
The top one, right? Top one and two. Well, you can use the computer on the third one, right? Okay, so these are most accurate. And technically, those are really the same method, just using a computer, okay? So today, I'm going to introduce to you method number 4. Okay? Which is, as the title implies, the sampling proportion. Okay? Now there's going to be some different things that we're going to be doing. So with the sampling proportion, I'm going to say that p hat equals x over n. Okay? Now, if I ask how many Donald Trump supporters, I don't want to ask that. How many Hillary Clinton supporters are there in this class? Okay? We could do an informal poll. We've got, pretending everybody's here, we've got 30 people here. 10 of you raise your hands. Okay? I don't think Donald or Hillary's going to get a majority of this election. Both are going to be terrible. But anyway, okay, so 10 of you raise your hands, let's say, and we count the number of Hillary Clinton's voters over the total, right? Okay? So that's just a simple, easy thing. You can think of that like a mean. We treat it like a mean, but we call it a proportion. Okay? Just the percent of people who support a proposition. Okay? Now, let's talk a little bit about the sampling distribution. Sampling distribution of p hat. Okay? So, just like with the binomial and the normal approximation, in fact, maybe I should mention this, p hat is approximately normal if NPQ is greater than or equal to 10. Okay? So that's exactly like the same thing we would do with our normal approximation, okay? No difference, okay? So maybe I should mention here, with the normal distribution, it has to be a large sample. We define large as greater than 10, okay? NPQ greater than 10. Now, by the way, with these two, they're not only the most accurate, but it can work on small or large distributions. It doesn't matter, okay? If I'm using the normal approximation, it has to be large enough. And if I'm using the p-hat, it also has to be large enough. These rules are exactly the same, okay? Now, 2, we would say that the mean of p-hat is, I like to use the letter P. Sometimes in the book they say mu sub p-hat. Okay, those are essentially the same thing. They're just two different types of notation. I'm going to really start hitting notation hard from here on out. But yes, so when I talk about p-hat or x bar, that means it comes from the, now they are the mean, but p-hat or x bar come from the population or the sample? The sample, okay? All right. Now, here's where we get a little bit different. So in this case, p-hat is simply x over n. By the way, well, I'll answer that question just a minute. The standard deviation of p-hat is known as sigma of p-hat, okay? Sigma sub p-hat. And that equals the square root of pq over n. Now, just as a reminder, if you're using the normal approximation, what does the mean equal?
That's just
NP, right? And what is the standard deviation equal? Square root of NPQ. What do you notice about those two formulas? They're really easy to confuse. One of them you multiply, one of them you divide. Okay? Now let's think about this for a minute. Okay? When we're talking about sampling distribution of p-hat, okay, generally you're talking about 30% of people support Hillary Clinton, or 10% of people support Gary Johnson, or whatever. You're thinking of percentages or proportions. Okay? When you're thinking of a binomial, you're thinking of whole numbers. Okay? 17 people, 18 people. Now your mean might be 17.3, that's okay, but generally they're discrete numbers, they're whole numbers. Okay? They're numbers greater than 1. When you're doing a percents are numbers less than 1. So your standard deviation has to be less than 1 in this case. In this case, it's often greater than 1. That's why you're multiplying instead of dividing. Okay? So that's the biggest way that you can misconstrue these, is getting these two things mixed up. Don't mix them up. You've got to keep these two together. You've got to keep these two together. Okay? So a lot of times these are interchangeable. You can do a binomial or you can do a proportion. Now let's talk a little bit again about this. If you're doing the normal approximation and you want to figure out the probability that something happens, what is the thing that you need to remember? Two? Okay, so you're figuring out the probability that x is greater than 17. What do you have to remember?
Would that be which side of the distribution you're on?
Which side of the distribution you're on, but more importantly, I need to add or subtract, right? A half. Okay, remember that for the normal approximation? Because we're taking, this is a discrete distribution, we're using a continuous distribution. You're either going to need to add or subtract or both, depending on what you're doing. Okay? because remember, these are dealing with whole numbers. In this case, do you think it's a good idea to add or subtract a half? No, that's 50%. Okay? So you've got to remember that as well, okay? You add or subtract a half when you're dealing with a binomial, you don't do that over here. That would be a very bad thing. That would throw you way off. Okay? All right. So, a few other things here. We are assuming independence. Okay? Why can we assume independence? Because our sample size is large. Okay, because if this is big enough, we can assume independence. Okay? All right. So a lot of these can be done all three methods. This is the most accurate. These can be accurate as well. The question is, well, I think this would be a good test question, actually. Do this with the binomial distribution. Do this again with the normal approximation. Do this a third time with the proportion. That'd be a good test question. Or what if I just say, do this?
Your choice.
You get to choose, right? Now theoretically, you should be able to get it right, but remember, there's lots of equations. Now this is, these are divided, these are multiplied. These are multiplied, these are divided. There's lots of ways to confuse yourself. Okay, so you remember, these two go together, these two go together. Okay, these go with this goes with proportions. Okay, so this is once again, multiple ways to do the same thing, multiple ways to get confused. Okay, how many z-score equations do I have for you? How many? Too many. How about if I add one more? Okay, so if you're going to use a z-score equation here, now conceptually it's the same thing. I'm going to convert this to a standard score. I'm going to say p hat minus p, and sometimes they put a piece of naught here, I don't really care about that. But anyway, divided by the square root of pq over n, okay? This is the notation. Now functionally these are the same. Essentially what I'm saying is you're taking your data minus your mean, you're dividing it by your standard deviation, and then I've already got the square root of n in there, don't I? Okay? So here's another z-score formula for you. Okay? So just remember, functionally, it's the same thing, it's just with some different letters. Okay? All right, so let's do an example here. The Gallup organization says 82% of Americans think moral values are getting worse. Suppose we obtain a simple random sample of n equals 80 Americans and determine the percent who think morals are worse. Okay? Now, remember I've told you before that we've got lots of ways to do this problem. I'm going to use the 8.2 method today. Okay, that's what I'm going to expect you to do on the homework. When this comes on a test, and you don't know which section this came out of, how do you look at this and say, oh, I should use the sample proportion method. Yes, Marissa's right. So you're looking here, you see a percent right there. Now, you've got to be a little bit careful because you should see those in binomial distributions as well.
But in this one, it asks for the percent.
It's
right?
asking for the percent. Okay, now you could use this with the binomial method, or you could do it with the normal approximation by the binomial. I'm going to do it today with the proportion method. Okay? So that's what I'm going to concentrate on today. Okay, but theoretically you could do those the other way as well. Okay, so the question is, can I use the sampling proportion method? Yes, because what's greater than 10?
You need to calculate.
I need to calculate it first, right? Okay. Now, let's also think about this. If you were doing a real poll, is 80 a very large sample? Probably not. Okay. So, how do we find out this is big enough? NPQ must be greater than or equal to 10. So N in this case is what, Brendan? Me? 80. 0.82. 0.18. So if I do that here, equals 82 times 0.82, no, 80. 80 times 0.82 times 0.18, I get 11.808. Am I big enough? Yes. Okay. So therefore, I can do this. Now, one of the things we're going to have to figure out is we're going to have to figure out our standard deviation. What is my standard deviation? Ryan, what do you think? Very good. My last class at NPQ. Okay? Excuse me, I almost wrote it. PQ over N, okay, in this case. Okay, so that's a different formula than the one I just taught you a few days ago. Okay? So remember to keep them straight, which one goes with which, okay? In fact, they said, oh, just take the square root of that. That doesn't help you in this case. It's a completely different number. If I do this, so the standard deviation equals the square root of 0.82 divided by times 0.18 divided by 80 in this case, I get a standard deviation of 0.042, about 4%. Okay? Does that make sense? All right. So in this case, it's 0.04, whatever I said, 295. Okay, so let's say, for example, because I didn't write down a number here, so you guys can help me make up a new problem here. Okay. Let's say that instead of Americans, you did this in Utah Valley, and you wanted to see what is the probability that people in Utah County, well, I gotta make up a number here. What number do you want it to be out of your 80 people that think moral values are getting worse? What? 70?
79.
Let's go with 70, that works. Okay, so you do your poll and you say that 70 people say it's getting worse. Okay? So what is the probability that people in Utah County, so what is 70? So we can figure out our p-hat in this case. P-hat would equal what? 70 over 80, which equals 70 divided by 80, 0.875. Okay, so we think, so we got a value of 87. Now, they only had 82, right? Okay, so what is the probability that Utah County is greater, has a greater proportion of people who think it's getting worse than the national average? okay? So how would you figure that out? With Brandon.
Which one from the z-score?
Exactly right. Find the z-score. So z equals what? 0.875 minus 0.82 over. Now here's the question, do I use 0.82 or 0.87 here?
Two.
0.82, okay? Pay attention to your thing here. I'm going to use the national average here. Okay? So 0.82 times 0.18 divided by
70.
is it 70 or 80?
80.
80, right? Remember, my p hat is x over n, right? So 70 is x, n is 80. Okay? All right, so we do this, and we get equals 0.875 minus 0.82. I'm just going to pull my standard deviation down here. Equals this number divided by that number, and I get 1.28. Okay? So this gives me 1.28. What does that mean? That's my z-score, right? Okay, so let's think about what's going on. WWRD. What would Rick do? Rick would draw a picture. He's not a very good artist. He can draw a bell curve pretty well. Okay, what's going on? A mean of what? 0.82. And I got a sample mean of 0.875, right? Okay. What area do I want to shade? I want to shade the right side. If I'm using my computer, what is Excel going to shade me? The left. So therefore, if this is my z-score, and I want the right side, how do I get the right side? 1 minus norm s dist of that. Okay? I got a value that says, p-value in this case is 0.1001. Okay? All right, so in this case, do you think that there is a significant difference between people in Utah County and the rest of the nation? Or is it within the margin of error?
10%.
Because you think about that, this is only difference by 5%, right? What do we call something that's unusual?
Less than 5%.
What is it?
Less than 5%.
Less than 5%. So is this unusual? No. So are Utah County people any different than the rest of the nation? No. Now in my last class, it was kind of interesting because rather than picking 70, they picked 78 people out of 80. Okay? So if you do 78 out of 80, that works out to be 0.975. When you do the math, the answer was like 0.001 p-value, which was significant, right? So in that case, it was, even though my sample size was pretty small. Okay, so quiz tomorrow, 8.2. See you all tomorrow. If you like learning all these